So, so we're going to talk more about our unit circle. Now, what I'm going to show you guys now is talking about where trig functions are positive. So, so this is like basically, so I'll write this out. So where now this doesn't seem all that useful right now, but in a few minutes here it'll make more sense as to why we want to know that. It tells us, if we know where the trig function is either positive or negative, it tells us where it should be in relation to all the other ones. So we have different quadrants here. And if we start everything in the first quadrant, like so sine, cosine, tangent are all positive in that first quadrant. So we're going to put a capital A there for all. Yeah. So including the cosecant, the secant, the cotangent, everything's positive in that first quadrant. So all are positive there. Now, depending on which quadrant we're in, it will determine if it's positive or negative. So if you look at the warm-up question, letter B, cosine in this quadrant was negative. And that's going to be helpful if you're checking your work. So going into letter B, I knew cosine was already being negative. The way I know that is this acronym that we use. And it's not a very catchy thing, but once you hear it, maybe you'll remember it. So it's all students, so S, and we'll talk about what obviously that takes, stands for, take calculus. So now, if you think of a cooler acronym, go ahead, but it's just a way to remember kind of that, please excuse my dear Aunt Sally, like.
You could have done CAS.
That was order of operations. Oh, that's like.
Sometimes alligators take.
Yeah. What's the planet one? Yeah. I don't think I ever learned it, so I literally like the first few planets I know, and then after that I start guessing. But okay. So okay. So guys,
All students take cookies.
all students take calculus. Yeah, all students take cookies. Yeah, something other than that is fine. Okay, guys.
That's how you say it.
But guys, what these are for though is to help us know which quadrant we should be in. So the S stands for sine. So sine is positive in this quadrant, but also. Sine and cosecant go together, so I'm going to put cosecant even in there if that's, well, yeah. Because cosecant goes with sine, but the S stands for sine. What do you think the T stands for then?
Tan and cot.
So tangent would be positive, and so would cotangent would be positive in that quadrant. Now that means the other ones are negative. So in that quadrant, sine and cosine are going to be negative in that quadrant. And then the C is going to be our cosine is positive, and then secant goes with cosine, so that gets grouped in that same category. Now this is going to be helpful as we're trying to figure out which quadrant we should be placed in. So that's going to help us with these next two problems. So they give us some information here about our trig function. Has everyone got this?
Maybe.
So tangent is 5/12, and they say where sine of theta is less than 0, find the sine and cosine of theta. Now they're telling us what about tangent here, other than it being 5/12. What's that?
The opposite.
It's positive. So yeah, they're telling us it's positive. They're also telling us the opposite over the adjacent. We have to figure out which trig or which quadrant we're in. So this is where we go to the all students take calculus. Now it tells us tangent is positive. So that means we're either in these two quadrants, but they tell us sine is what? Negative. They're telling us sine is less than 0, so that means sine is negative. So sine is positive here and here, so we have to be in, so we basically can cross off these quadrants because of the fact that tangent's positive and sine is negative. Are we okay with that?
Okay.
All right. Now I'm going to draw my triangle. And I always draw my triangle and going back to the x-axis. I don't know what that angle is. At this point, I don't really care what that angle is. I want to figure out the other trig ratios. So again, they're telling us the opposite over the adjacent. So opposite is 5, the adjacent is 12. Now, in this quadrant, shouldn't both of those be negative?
You would say so.
Yeah, but why did this end up being positive? Two negatives are a positive, so it makes sense that they're negative there, but they end up being positive in my fraction. Now I want to figure out what sine and cosine are of theta. Now I should know that they're both going to be, what kind of sign? S-I-G-N sign. They're both going to be negative, right? Because they're both in the quadrant where just tangent is positive. But what am I missing if I want to know sine and cosine? And we need to find the hypotenuse. So we're going to do some trig to figure that out. Now this actually happens to be a special right triangle, but you probably haven't talked about special right triangles for a while, so works out nicely. What does x end up being? Anyone get it yet? 13. So our hypotenuse is 13. Remember the hypotenuse, we always assume it's positive. So now we know the hypotenuse, so now we should be able to figure out sine and cosine. So sine is opposite over hypotenuse, and cosine's adjacent over hypotenuse. And again, those should both be negative. All right, why don't you guys take a minute then on this next one, I'll leave it. Now the next one asks for all 5. If you just want to find the other 2 right now, that's fine, but if you want to list all 5 right away, see if you at least can figure out which quadrant you're in. I'll give you guys a little bit of time for it. See if you can determine what quadrant you should be in. So you can get it set up and find that missing side. doing? You ready? Alright, so this one's a little bit trickier because it wasn't a nice number as our missing sign. So it says let sign be a negative value. So automatically, hopefully you realize that our we have to go in the quadrant where sign is negative. So all students take calculus. So we can't be anywhere where sign is positive. But then they tell us cosine is what? Positive. So we're going to go where cosine is positive but sine is negative. So that's down here. Now they're telling me my opposite over my hypotenuse. Now when I have a negative 1/5, either the top or the bottom is negative. And since we know hypotenuse is always positive, the top is a -1, and that makes sense because that's my opposite side. And then our hypotenuse is 5. So we need to find the adjacent side. So we do 1 squared is 1, move it over, it's 25 minus 1, so 24. When you go to simplify the square root of 24, either your calculator does it, or you realize that square root of 4 can be pulled out, so it's 2 square roots of 6, and it's positive. So now we need to find the other 5 trig ratios. So cosine of theta is adjacent over hypotenuse. That one's easy because the radical doesn't show up in the denominator. Tangent is a little bit trickier. So we do opposite over adjacent, but I can't leave that radical there. So I'm going to multiply by the square root of 6 to the top and bottom. And the bottoms become 2 times 6, which is 12. Don't do that. Now, as much as you want to, negative square root of 6 over 12 does not simplify. You can't like pull that 6 out of there. Then they're asking for the other ratios, and that's just a practice of you guys just trying to remember those other ratios. So sine goes with secant. No, sorry, sine goes with cosecant. My board's really needs to take a break. All right, so sine was negative 1 over 5. So this is going to be negative 5 over 1, or just negative 5. Secant, we have to flip the cosine. So have to flip that. It's going to be 5 over 2 root 6. And cosine should be positive here. And then tangent goes with cotangent. That one's actually not too bad. I'm going to flip the original one. So it's 2 square roots of 6 over negative 1. So a negative 2 square roots of 6. All right, questions there? Okay.